Hello everybody, welcome back. It's Dumplet here, and welcome to another calculus item, particularly on limits. Evaluate the following limit. The limit of 3 raised to x minus 1 all over 27 raised to x minus 1 as x approaches 0. As usual, pause this video if you want to give this item a try, and if you're done, let us dive into the solution. Now, there's a lot of ways to solve this item. You can use factoring, you can use the table of values if you'd like, but today I'll be showing you guys the concept, the Lopitals Rule. The Lopitals Rule tells you that you can get the limit of a given expression as, the variable approaches a certain value via differentiation. Now, before we can use the Lopitals Rule, we must first check that the format is indeterminate. Like if we substitute, for example, as x approaches 0 here, so if we make the substitution x equals 0, we're going to end up in an indeterminate form. Now recall some of the common indeterminate forms: 0 over 0, 1 raised to infinity, 0 times infinity, and other similar forms. Now, if x equals 0, 3 raised to x is 1, then 1 minus 1 is indeed 0, and then 27 raised to x, 27 raised to 0, that's going to become 1, 1 minus 1 is 0, so now this limit, this expression, if I substitute x equals 0, I'm going to get 0 equals 0. Therefore, I can apply L'Hopital's rule in this expression, in this limit. So, L'Hopital's rule tells you that if you have a fraction like that, or a rational expression, we can simply take the derivative of the numerator and the derivative of the denominator, and then evaluate the limit. So, we can actually say that the limit of 3 raised to x minus 1 all over 27 raised to x minus 1 as x approaches 0 is the same as the limit of the derivative of 3 raised to x minus 1 with respect to x all over the derivative of 27 raised to x minus 1 with respect to x as x approaches 0. Now, this is true by L'Hopital's rule. All right, so don't forget to check the very basic thing. If I substitute the value that x approaches to, I should be getting an indeterminate form before I can use the L'Hopital's rule. All right, so after this step, all we have to do is to get the derivative. So we take the derivative. So recall the derivative of an exponential function. So we have the derivative with respect to x of a raised to x for some constant a. This is equal to the natural logarithm of a times a raised to x. Hence we have the answers, hence we have ln 3 times 3 raised to x. The minus 1, if you take the derivative of negative 1, it's a constant, so it's just going to be 0. So the numerator just becomes ln 3 times 3 raised to x. Now, similarly for the denominator, the derivative of 27 raised to x is ln 27 times 27 raised to x. The minus 1 will just become 0 since it's constant. So we have ln 27 times 27 raised to x in the denominator. Now, this limit is equivalent to the limit that we have in the item. So we have these two are the same since we applied L'Hopital's rule. Now, we have to check. If I substitute x equals 0, will it work now? And yes, it will. Because we're going to end up, if I substitute x equals 0, I'm going to end up with the expression ln 3 times 3 raised to 0 all over ln 27 times 27 raised to 0. Now, it's obvious that this is just equal to ln 3 over ln 27, since 3 raised to 0 and 27 raised to 0, these are both equal to 1. All right, so all we have to do is just simplify this and we would be able to get our answer. So Now it's just a concept of logarithms. Now I will rewrite ln 27 as ln 3 cubed because 3 cubed is indeed 27. Now take note of the property of logarithms. The natural logarithm of 3 raised to 3, I can put the exponent in the front. So the 3 can be brought into the front, giving us 3 times ln 3. Now since there's an ln 3 in the numerator, we can cancel ln 3 and ln 3, giving us 1 in the numerator. Hence, we'll arrive at the answer of 1/3. Now, the series of equalities will connect to the original given via Lopitals Rule and just some simplification. And this is the final answer. So we have 1/3 to be the final answer. So Lopitals Rule is indeed helpful when you have indeterminate forms. So whenever you come across a limit that is going to be indeterminate, if you substitute the value of x that it approaches to, then you might want to consider making it of this form, or like a fraction, and then take the derivative of the numerator and the denominator to help you solve the limit. Hope you guys enjoyed this video. Hope you guys learned something new from the video, and I'll see you guys again next time. Bye bye.